welcome everybody to lecture 3, Database and Information Systems on Database Basics today, winter semester 23-24. This course can also be taken as information retrieval. So this is, we will first talk about exercise sheet 2, ranking and evaluation, something about the exercise sheets and the exam. You will see this is a brand new lecture. I've never given it before. We have spent a lot of time preparing it, at least 20 hours, probably much more. I hope you like it. I think it came out very well, but let's see. So we will talk about its databases and information systems. I know a lot about databases, haven't given a lecture about it before, and we will start with the very basics, but you will see that already the basics are quite interesting. Tables, we will look at the simple system design and some basics on the query language. And the exercise sheet, we will talk about that. First, about your experiences with the last exercise sheet. First 2 lectures were about search engines, so Google, how this works in principle. Now we are going to databases, so you wonder, is there any connection? Right now there's no connection, but already in the next lecture and later you will see that it's all connected. Everything is connected. So, excerpts from your feedback. You found it interesting. Those who did it, significantly more work. Lecture was well explained. Here are some quotes. Overall good task. The lecture really did help to understand it. Great lecture again, once again, very nice to follow. About twice as time consuming as the previous sheet. I mean, the first sheet was really just getting started. There was discussion. Some people even wrote, I heard a factor of 3 in one. Okay, it was conclusion, man, this is difficult. This was not referring, I think, to the sheet, but tuning parameters, right? It was, you had this training and test benchmark, you had these parameters B and K of BM25, and just getting good results, we will see it on the next slide, is hard, but that's typical research work. Problems, understanding average precisions. So there was a post in the forum, there was a slight mistake in the explanation that led to some confusion. That can happen, of course, but it was clarified on the forum. The 80-character line limit is annoying. Yeah, but it's standard. This comes every semester, at least one person says it. Why? It's not coming from us, right? And this is, let me spend 1 minute on this because it's so typical and says a lot. I understand it that this comment comes, and it's look, why am I spending this 1 minute? It's a typical instance of this, my view as an individual and the world as a whole. You say, I have this wide screen, I have 320 characters. Why am I limited to 80 characters? Why do I get the sound effects? There's no hair right now. Höher oder tiefer, okay. So you say, I have this wide screen, why 80 characters? Well, other people don't have this wide screen, and then there are all kinds of tools which show code in a particular way, and I haven't prepared this now, but a typical view on GitHub, if you work on big projects, is that you have your 2 versions of the code side by side. The new code, when you open a pull request, and the old code, and then you have it in 2 columns. Just one example where, and then if your code has very long line and it breaks, it's totally unreadable. But it doesn't really matter. The point is, it's a standard, everybody uses it, and it's very hard for humans. You start, you see only your perspective, and you say, this is annoying, can't we just drop this? If something is a standard in a very big community, there are probably very good reasons for it. But it's interesting that every semester people fight with this. But it just says something about how humans work. I like that we are building something more complicated step by step. Yes, will become more complicated even. We suffered physically and mentally, I hope not due to the exercise sheet. I think I was not sure what this was referring to. Please give us nice feedback, yet we will. Unfortunately, I did not have enough time to finish this sheet. Several people wrote that. Thank you for being so honest. And I will come back to this in 2 slides. Just very quickly, the results. There were these 2 parameters. I'm not repeating the explanations from the last lecture, just saying there was this PM25 formula with a parameter B and a parameter K. The parameter B tunes how much do you take into account when one document is very long and the other is very short. Of course, the long one contains words more often. Somehow you should adjust for this. For our collection, which was movie description, it turned out that a little adjustment, not a large adjustment, a little, but also not 0, gave the best results. That's over the years, we are often doing this benchmark. This turned out to be the best setting. Small values of K, and understand again, or try also when you did the exercise or when you do it again, a value of K corresponds to TF star, so adjusted term frequency in the range 1 to 2. Understand that. So if the original TF, which just counts how often a word occurs in document, is not 0, then it's 1, 2, 3, it's an integer, can also be 15 if the word occurs 15 times. With this formula, with K1, it means if it's there once, the value will be 1. If it's there very many times, it will approach 2, somewhere in between. So at least we see that this formula makes some sense. A non-zero value of B gave the best results, and a value of K which was larger than 0. If you that we discussed also in the lecture, if you set K to 0, you just get the normal formula. So baseline results. These were the results. So we deliberately, so Sebastian did the solution. We always do the exercise sheet. We always solve the sheets before so that we see that everything works. And he deliberately did not put a lot of work into getting great results so that you could do better. These were the results he got. These were, I think, the best results, at least when I looked at the table. And you see there was room for improvement, but you also see something here which was kind of an important message of this sheet. These are typical, even good results for, if you look at, I mean, this is precision at 3, is you look at the top 3 documents. So how many of these are relevant? Ideally, of course, you want 100%. All the top 3 are relevant. We're pretty far away from that. Here you average over all relevant documents. You really also care if there are 17 relevant documents in your ground truth, where the position of the 17th one is. And here we get values below 50%. But this is typical. This is a common measure. It's a very hard measure. You won't see a benchmark or a method which gets you close to 100%. Think about it. You have a big corpus. For the exercise sheet, it was just 100,000 plus. For web search, it's billions. You have, in our corpus, 17 documents, and among these 100,000 plus, you want the all 17 at the top, and only those. That's a very, very hard, extremely hard problem. So these are typical scores. And here's another very important remark before we go to the actual content. So already we were surprised. So this semester, it's voluntary, you don't have to submit. And already for the first sheet, we expect that in the end, I think 180 people or so will write the exam, or maybe 160, just estimating from the number of people who signed up. It's always more, over 300. It's about half which then write the exam. And we only got, how many? 60 or 80 submissions for the first sheet, something in that range. Now it's down to 40, which means 25% of people are submitting. Most of you are not submitting. Of course, it's up to you. That's the rules this semester. But let me tell you a few things. And already, and that's why I'm coming back to this comment. I mean, I'm happy that you are so honest. Already now, even of the 40 people who submitted, half wrote, I don't have time, I didn't finish. It means the second week of the semester, already people are not having time. I see a problem here, and I want to spend a minute on this. So for the exam, you eventually need this stuff anyway, right? I mean, In particular, writing code, of course not writing code 100 lines like for the exercise sheets, but 10 lines is an important part of the exam. Just look back at the exams from previous year. And especially with coding, but actually with everything, also with mathematics, everything, only practice makes perfect. If 2 weeks before the exam you start, oh, I need to write Python code, let me just look at a little bit of Python or write a few programs. Too late, only practice. Practice means regular practice. It's like this with everything. So if you start practicing your code 2 weeks before the exam, it's too late. And I mean, we have been doing exams for decades, and we always see code by students also in oral exams. It's absolutely clear this person has not coded in a while. Please don't be one of these people, right? I mean, use the exercises. We put so much work in the exercises. We have 5 tutors, more than enough, I think, and use the opportunity to practice, get individual feedback. You also don't get that if you do it before the exam. And I think something is wrong if already now you don't have time to do the exercise sheets. I mean, then you should just cancel this lecture, cancel one of the other lectures. So please take this opportunity. And and this is obvious, right? Only when you work on something you realize whether you actually understood it. These lectures are entertaining, but just listening to them, I can't say that often enough, you don't learn anything by just listening. It's 98% entertainment, and it goes into one ear out of the other. You have to put it to use, and a typical symptom is shortly before the exam we get all these detailed questions. And slide so and so, what does this actually mean? People even find small mistakes, obvious mistakes even. Nobody found them in the second week of the lecture. Why? Because you haven't really paid attention. You haven't really thought it through. I mean, this should happen now, ideally in the lecture, after the lecture. Something is wrong if we have 160 people participating and even small errors on the slide get pointed out shortly before the exam. Will we have to write pseudocode or Python code in the exam? Yeah, very good question. It has to be Python code, of course. It has to be the code you are not allowed to write pseudocode. You see it in the exams. Both are the same. That's not true. Of course, since you are asking that, if you make tiny, we don't expect you to write Python code which compiles out of the box, although I would argue for a 10-line function, it's not that hard. So if you miss a small syntactic thing, you don't get subtraction of point for that. But if you write code which looks like you haven't really written Python code in a long time, there will be subtraction for that. So you should know Python. Okay, that is that. So that's 3 minutes over the time I reserved for this. So please take this to heart, what I just said. And now let's start with databases. Databases is a fascinating topic. And we start with tables. Databases is all about storing data in tables. I think the lecture is relatively lightweight, but please, even more so, try to pay attention and see if you really understand it. Structure of a table is defined by its schema, and here we have an example table, and we will work with that in a second. So that's what databases is about. You have a lot of, and we keep with our movie theme, you have a lot of tables like this, and a table, let's look at the components of the table. You have the headings here, the headings. That's called the schema. The schema has two components. One is just the name. Names are title, year, score, and of course they mean something. And we will see on the next slide, we have a formal definition, the domain. So what's supposed to be here? Title, that's strings, movie titles. It doesn't have to be, the domain doesn't have to be defined very narrow, but just from which set do the values come. So here, all strings. Year, integer. Score, it's a floating point number. We will see it on the next slide, and we have more in the following. And then we have the contents of the table, and it's just rows. And there's nothing hierarchical here. Let me just get this clear right from the beginning. It's not tables like in HTML where you can split a cell vertically, horizontally, or anything like that. It's just tables like this, the simplest form of tables. Columns are fixed, and then you have rows. And the rows, and that's also important, it's written here, once you define a table, the columns are fixed. You can't add another column later, but you can change the number of rows. You can insert rows, delete rows, and the table can also have 0 rows, and it's an empty table. So, all of databases somehow based on this model. It's a very simple model. It's just a formalization of what I just said. It's a table with k columns, and I think it's easy enough to understand, just putting it in a little bit more mathematical way. You have the column names, which is just a tuple. Why a tuple? Because the order matters. It's first column, second column, third column. Then you have the domains, 1 per column. And let me just see. Yeah, here's an example. Let me put the example first. So C, these are the column names, title, year, score. The domains, all strings for title, all integers for year, all floats for score. And then this is a set of tuples. Set is important. We have 2 slides about this. This is a set, so the rows do not have an order. The order doesn't mean anything. The columns have an order. I have to know that this one is actually the title thing, right? And it's a multi-set. What does that mean? We will see in a second. And this is not blue. I hope you, this cannot stand. We have to correct this immediately, otherwise we cannot continue with this lecture. Okay. So, please do ask a question if anything. I mean, it's simple enough, but still, minor things might be unclear. So that's our table just written as sets of tuples. Same thing as we have seen before. And why does it say, first it says set here and not, right? The order does not matter of the row, and it says multi-set. That's important. It's actually very important, which is why I have 2 slides on this. So a set contains each element at most once. That's a set 1, 3, 7. Each element from the domain is either in it or not. This set has 3 elements. This is a multi-set. In a multi-set, I can have any one element in there multiple times. So the 7 is contained 3 times in here. That's a multi-set. That's why it's called multi. You have a notion of multiple occurrences, and you also know how often an element occurs. So this multi-set has size 5. Which means, just going back to the table, I don't have an example here. You could have this line, the second line, the Dark Knight 2008 9.0, repeated 2 times. So it's there 3 times. And then it's there 3 times. And you also have the information that it's there 3 times. This you can do. And it's also important to understand that in the original, when you do database theory, you don't have that. You have sets. And the original paper is in the references from 1969, so databases is a very fundamental thing. Modern databases allow multi-sets by default, and so we will also do that in our definition. And there's a very simple reason. Understand that if you can insert or delete rows and you want to disallow duplicates, this costs time and space. You somehow have to check, build a hash set or something. Okay, these are the rows I have. Now comes a new row. Is it already in there? So it's easier if you don't have to check this. If you want to insert the same row twice, fine, just do it. That's why multi-sets are the default. However, most systems will allow you, when you create the table, to say something like, please check for uniqueness. And then when you insert the same row twice, the database will ring an alarm, say error. But that costs time, so it has to be done explicitly. Also important, I mean, it's simple but important, neither of these have an order. So let me go to this slide again here. In this table, the columns have an order, the rows do not. Of course, when I show them, I have to give them an order. It absolutely makes no difference semantically when I change Inception with the Shawshank Redemption. Same table. Just have to understand this. Okay, so even if you insert them in a particular order, I insert them in the order I've just shown you, the database does not have to keep or remember that order in any way. So there's no way to say, give me the first row I inserted. You just can't do that. It's simple, but you have to understand this stuff. And actually it's important because a database efficiency is a big topic, not today. In the next lecture we will talk about efficiency. It can make things more efficiently when it's allowed to reorder rows, and databases do that. However, I will come back to this question in the chat in a second. If you need an order, maybe it's important for you that the database remembers the order, then simply have an additional column with a counter, right? You can just do that. Let me just go back to that slide again here. Where is it? I can just have a counter column here at the beginning and just remember 1, 2, 3, 4. So I can just do that. And their database systems even have a way to specify in this column, I don't even have to say it, just increment by 1 whenever I have a new row. But only do that when you need it. I mean, then you have to store that column, cost time, cost space. So there's a question. Regarding the schema, what about alter table? Alter table. Okay, that's a good point. There is... Where did I say this with a fixed? It's a good point. Is alter, actually we haven't looked at, does alter table exist? Or did you just make it up? Because I don't know. I've never used alter table in my life. But alter table. Yes, there's alter table. Okay. It has all kinds of problems, but we'll talk about that more. But thank you for pointing it out, but there is alter. Alter means not alter, but alter, to change, alternate, altering something, alter table. Let's not talk more about this, but okay, this is, it has problems. You shouldn't do it, basically. You shouldn't. Changing the schema of a database is terrible. So, but thanks for pointing it out, yes. So, where are we? We are here. Multiple tables. So that concludes the tables part of the lecture. It's very simple. You have tables. We have seen some things which we need to remember. Of course, in a database you don't have one table, you have multiple tables, and all of the rest of the lecture will be about that. Tables can share columns. So here I had the title of a movie here. Maybe I have the title also in another table. Nothing wrong with that, and as we will see, it's actually important. Because if the tables all have totally different columns, you can't do much with them. You need to combine them. They need to have something in common. And this is what much of the exercise will be about. If you have many tables, how to store your data in tables, which tables to choose, how to pick the columns. That's actually challenging, and much of the first exercise is about it, so-called database design. And yeah. That will be, and I have a whole section about this in a second. And then, of course, you have queries. So you have, your tables, all your tables and your data in there can be very large. Now I want to ask something. I want to extract data from these tables. And there's a query language. It's called SQL. It's called Structured Query Language. Tables are what is also called structured data. Basic SQL queries are really easy. Here's I don't go back to the table. You have seen it so often now, the table, year score table. I can say, from this table, from movies, we called it movies, select just the columns title and score, so forget year, and only take those rows where the score is greater or equal 8.0. And I forgot a semicolon here, which is a deadly sin in SQL, but I realized it. And you can see, that's why I'm showing it already here, SQL, basic SQL, you can just read it like a sentence. Even if you have never seen SQL before, you can understand what this does. Of course, SQL is Turing complete. You can do everything with it. You can use it as a programming language, so the complete language is very complex, but simple SQL queries are very easy to understand and write. There are very many dialects, so basically every database system has its own version of SQL, but the core functionality, so a query like this will work exactly like this with every database system. Today, I will not give you a full introduction into SQL. I will not even give you a formal definition, but we will just learn SQL by example, and that will be enough for the exercise sheet. Also just a few example queries there. In the next lecture, we will be more rigorous about this, but today is the introduction. Okay, enough of the theory. Now let's look at a concrete engine. So you need systems implementing this. System implementing this stuff is called, has this nice name, which is, you will find this a lot in the literature, Relational Database Management System. Relational Database Management System, RDBMS, so you should remember this, RDBMS. This is a very common abbreviation, not acronym. Is it an acronym? No. Okay, so there are very many rhythms on the market, commercial as well as free, open source as well as closed source. Maybe you have heard some of them, MySQL, Postgres, many of them have SQL in their name, Microsoft, SAP, the big German company has their own database system. Many companies have their own system because they rely on database technology, Oracle, and we will use SQLite 3 in the lecture. Actually, setting up a database system can be pretty hard, not SQLite 3. I will show it to you in a second. It's fully functional, so it can do everything, really everything you expect. So, and it's super easy to use, so that's why it's called Lite. SQLite in 3 because it's the version 3. It's also reasonable. It's not the most efficient system, but it's not bad. So actually many other frameworks which use a database use SQLite 3 in the background because it's so easy to use and very comfortable. And we will now provide a crash course. And as you can see, this section is just 4 slides. This was already the first slide. It's very easy to use a basic database system, which is very nice, and you will also use it for the exercise sheet. So you can just install it like that. Now I'm not sure, is it installed on our Linux image, Sebastian? Maybe not, right? Because but you can install it yourself. So on Debian Ubuntu, if you have Mac, you use Brew. If you have CentOS, you use Yum or whatever, so apt is what you use for Debian. There are 2 modes to start it, simple enough. SQLite 3, then you get into interactive mode, and let's maybe just, so I can just here on the command line, SQLite 3, now I'm in SQLite, and now it's like you can also use Python interactively, and now I think the hardest part of SQLite 3 is getting out of SQLite 3. So if I do, this doesn't work. It worked. Oh wow, this is new. I did it. So if I do a quit, doesn't work. Okay, exit doesn't. So you see, it's not so easy. Control C doesn't work, but it's .quit. Now you know it. You can say whatever you do, maybe in the system you will create tables and stuff, you will ask queries. If you want to record this, you call it with a file name, and that's then the database, and they're stored in that file. And if that file exists and you call it like this, then you already have all your tables in there. We will see that in a second. We will do it. We will work with SQLite quite a bit in the following. Now important, there are two types of commands, not really commands. One is the SQLite commands. They start with a dot, so we have already seen the most important one here, dot quit. That's not SQL, that's SQLite, so of this particular system. These commands start with a dot. And there's SQL, so the SQLite commands of the database system, they start with a dot and have no semicolon in the end. And SQL commands don't start with a dot, but have a semicolon in the end. So that's really confusing, but that's how it is. Okay, so that's already the second slide. And here are some useful commands, and we will put it into practice in a second. So somehow, if you read data from a file, you have to say, and let's just start right away. Let's maybe, I use NeoVim. Let's have a file, movies, TSV. This is also something you should do for the exercise. And maybe let me use that occasion to already jump to the exercise sheet. So here's the exercise sheet. Let's see if it works. Okay, this is geheim. So, and the exercise sheet, so you have to work with data, and it's part of the exercise sheet to gather the data. Because you have to come up yourself how to put that data into tables. So we can't really give you any data, because if we give you the data, we are already giving something away how you should do it. So you should really start by looking up the data yourself. So it will, we will keep with the movie themes. We have selected 4 movies for you: Fargo, Kramer versus Kramer, 3 Billboards Outside Ebbing, Missouri, Titanic. Who knows all 4 of these movies? What? Who knows 3 out of 4 of these movies? 3? Okay, who has watched 2 out of 4 of these movies? Who has watched none of these movies? None? Okay, and 1 out of 4? Okay, that's most. 1. Which one is it? Titanic? Interesting. Wow. You're not much of... What are you doing in your free time? Anyway, so I think that's... movies are... I think half of my education is from movies. Okay, you can click on these links. They are not underlined. You can also click on this link here. We don't underline them. If you go there, you get to the IMDb movie page. So here we have, I don't want to buy a car right now. Here we have Fargo. Fargo is a great movie. And you have all the information you need. So that's the first part of the sheet, is just go to the sites of these 4 movies and then gather some data. The IMDb score, the year, who directed it, who produced it, not all the cast, too much work. So this is some work, but it shouldn't be too much work, why we kept it a low profile. 4 movies, 3 actors, take the most prominent one, at least 1 male, 1 female, including the character played. So here it's, you see the plot here, so it's Frances McDormand, she played Marge Gunderson, police officer, so that's the kind of data you should gather. And the Oscars won by the movie. Now, Oscars, or synonymously Academy Awards, there are very many of them. Also, again, for the sake of keeping this simple, just restrict to these categories: Best Actor, Best Actress, Supporting Actor, Supporting Actress, Best Director, and Best Picture. Best Picture is what the producer gets. So you start with that information, and then you enter it, and that's already the second exercise, into TSV files, tab-separated value files, which we will now do for our movie data. And here I already gave you the data in a table. So where is it? Where's my table? Oh, it's up there, here. That was this table. But you have to think for yourself how to design that table, which is why we're not giving you the table. This is just here for explanation. So how does it look in tab separated value. So I have title, year, score, title. Now to type a tab in this editor, Control V and then tab, because if I do a tab, it's a command, right? So yeah, let me just delete this again. So I do Control V, you don't see it, tab. Now I get it. Tab character, then I get the year, and then I get the score. And now the first movie is the Shawshank Redemption. Okay, you see some magic here. The score is almost right, 9.3. Second movie is The Dark Knight. Okay, this was wrong here. The Dark Knight. 2008, 9.0, not bad. See the magics. Inception is the third one, not bad, right? This is, for those of you people criticizing large language models, they should do this. It's just, it's magic. This is just magic. Fight Club, no. I mean, I haven't even typed the first letter. This looks like this thing knows my slide, right? And it's, I mean, this is just amazing. This is just amazing. I just wanted to show this to you. In case you show this to your friends who, if you have someone who say, yeah, these language models, they are not that good. So now we have our table. It's a very simple table. It's there. And now we wanted to learn some SQLite. Let's go back to that slide. And now let's just do it interactively for now. So I just do the following, SQLite 3. And now, why not store everything in a database? So this is initially empty. And now I think I have to explain something first. Now I have to import that table into the database, this TSV file. I somehow have to read it, and we have seen a command here. It works like this. I think I can do it. Import movies TSV, movies. Yeah. And now it's in there, so it did it. It can just read the TSV file, we'll make a table out of it. If I type .schema, it now, that's interesting. There's it shows me the schema of the table. And this thing here, we will learn it in a second. That's already some SQL. So it shows me it's movies here, title, year, score. It's all text. We will see more about this in a second. I can write a simple select SQL statement here. Select star everything from that movie. This is about the simplest SQL query. Select everything from a query. Without ever having seen SQL before, it should be clear what this does. Select everything from that table, and this is now our table in the database. So you see, really simple to use. Now we already know how to quit. I leave it. And now I have movies DB here, and you see it has some content. So it has, because I have called it like this with some, if I would have called it without argument and I leave the program, now the data is done. Now if I call it again, it's just, it knows the table, it even remembers arrow up, arrow down, my commands, and it's just in that. So simple enough, right? That's SQLite 3. You will work with this, and it's a great program. Couldn't be any simpler. Okay, back to the slides. So you can import, you can read something. We will also do that I think I will show it to you right now. Let's just do, let me remove my movies SQL again. My movies my movies DB, my database. And let me write a file, movies SQL, where I just do what I just did, and I write it in a file. Movies, TSV movies, and then let me write that query. Thank you. I don't have to write anything. Select star from movies. That's what I just wrote. So that's just, and if I want SQLite to execute these commands, I can do it like this, for example, SQLite 3, movies sequel. And now it will just, this is read the commands from standard in. I can also do it like this, movies sequel. So this will just output the commands and pipe it into SQLite 3. SQLite 3, I don't have to give it any arguments. Now it will not store it in the database. It will just process these commands. So now it just imported the data and executed the commands. And now you already understood a lot about how SQLite works. That's basically all you have to understand. How you create a table, how you can import data, how you can ask Sparkle queries. So you can just have a file with commands. Then you can pipe it. That's also how you should do it for the exercise sheet. Pipe it into the program, and then you get results. Really nice. Just a random selection here. There's so many commands, of course. The big system, timer on, if you want timing information. There is help, of course. Let me just show it to you very quickly so that you have seen it once. .help gives you help. You can also do .help on a particular command. Now, confusingly, you don't write the dot, so it's .import, but .help import. Now you get information about how that works. So it's also very nice. You have the documentation inside the program. SQL commands, this is how you create a table, and we will work more with that in the following. You write create table. Actually, we have seen create table if not exists. We don't need that. Then you would get an error message if that table already exists, so that you do not overwrite it, because this, I think, will create an empty table. And here we see a few things. I haven't talked about them yet. I will now. This is, of course, the name of the table. These are the names of the column. And here we have the data type. This is exactly the domain from our earlier definition, right? And it's you can understand it by just reading the name. This is text, any string. This is integer, and this is floating point number. That's just how you do it. I think not only in SQLite 3, but in all database systems. These are very common names. And of course, they are different from how you do it in programming language, because every language needs to have their own name. So to just maximize confusion. Launch a SQL query. Yeah, it's just another example here. I will not try this out. It's also obvious from this table, select all columns. I could have also written star here because it's all column, but I can also list them. You separate them by commas. So as I say, we will do it by example here. You learn this, so comma separated, otherwise you would get an error. And then you can specify some conditions here also. Where, if you do that, you only get the movies where the score is greater equal 8.0. You can also delete a table. If exists, then you will get an error message if it does not exist. And on the last slide, but you can also just Google, I mean, it's not the job of the lecture to provide you a manual or something. There's the SQLite page, and there's also a page which is, I think, the one linked in the, it's called lang HTML. Yeah, here you have the SQL as understood by SQLite 3. Oh, here we have alter table, by the way. It's the first one. Vacuum, so if you need to clean your house, you can use that one, vacuum. So it's not that many commands. Okay, that's the SQLite part. And now I think, because we are just getting started, let's start with the design part. That's the main part of the exercise sheet. And that's actually, as I said, this is a brand new lecture. When I started this, it's so funny when you think about things. Sometimes you have thoughts in your mind, and in your mind it's just one thought. But when you work out that thought, you realize, oh, that's a big thought. It's a lot of things. And database design, in my mind, it was one slide. Now it's 11 slides. Because actually there's a lot about database design. And it's the main part of the exercise sheet. Let's see what I mean. 3 billboards outside Ebbing, Missouri is one movie. Yes, it's one movie. It's a very good movie. 3 billboards outside Ebbing, Missouri is one movie. that's the name of the movie, and there's a comma. We deliberately included a movie with a comma because, yeah, just so that you know that there are movies with a comma in the title. So we have seen one table, movie. Oh, it's called movies, right? I think it's just wrong. It's movies. I think it was called movies, yeah. And it's important to note, I don't show, let me maybe switch not to the previous slide, but just to the table here. Oh, I don't get, I have to type it just enough times with the right frequency, okay. Never mind. So here's our table, and actually, let me just show it more nicely. Columns minus S. That's, I think, a way to show, no column, it's called column, not columns. Yes. So this is how you show a table nicely on the command line. You do column minus S, this is also a tab character here, minus T, and then you see it. So that was our table, and note that every movie has exactly 1 year, exactly one score. This is why this is kind of the simplest thing you have in a database. Every movie has exactly 1 year, exactly one score. It's like functional. You give me a new movie, I give you the year. It can't have 2 scores. But that's not typical. Most data is not of that kind. Now let's talk about actors who played in that movie. Well, there's not just one actor for a movie, there are many actors for a movie. Yeah? Each movie. But how do we do that? What do I do now? Do I have an additional column actor here? And how do I do it? And now let's go through it. And I deliberately now X this out in the following by just, what are the first things that come to mind, and are they good or bad? And this is really, it's the central question. It's what's often done wrong. For example, his in one, which you all know has, I know, has a terrible database design, because it's hard to do database design. And let me also say that, this is so important, it's the first thing you do, right? You start creating a database, the first thing you have to do before you even start asking queries, you need a design. You need to decide, how do I put my data into tables? And then you are stuck with it. There is altering tables, but you should not do it, and you're stuck with it. Once you have a certain design, and then later you realize it wasn't that good, too late. So a very important problem, which is also why half of the sheet is about it. So what are the first things that come to mind? And these are solutions. I mean, I didn't put solution in quotes because it is a solution. Let's just have an additional column, and let's call it cast. Cast is actually, I should have called it, yeah, we'll come back to this. Oh yeah, I already said this is a terrible solution. Okay, I should have changed the order of this. Let me change the order of this before let me just go to, you haven't seen this, just forget it, just delete it from your memory and look away, just look away. So I'm live, bam. So, here we have a table. Is this a good solution? Yeah. Is this a good solution? And just look at the table and think about it. You haven't seen the red thing, the last minute was erased from your mind. I need a pendulum. The last minute has been erased from your mind. This doesn't look so bad. And actually that's important. People do it like this. People do this stuff. They say, yeah, it's a database. And the database, of course, allows you to do this stuff. So here I have the actors. Shawshank Redemption, or let's maybe take, I don't know, Inception. Leonardo DiCaprio, Elliot Page, Marion Cotillard. And other actors, separated by commas. Okay, it's a terrible solution. Why? Now you have, let's say let's look at one query. Do The Dark Knight and Shawshank Redemption have an actor in common? Now I have to take these two strings and look, somehow parse it, separate it by comma, put it in a hash map, stuff which actually the database is supposed to do, I now have to do myself, check whether they, and maybe there's an actor which has a comma in their name. I'm sure that there are movies which have a comma in their name, so probably also an actor with us. So that's bad. It's also, let's say I want more information, like Morgan Freeman, or what did we have? I don't have the, I don't know. Christian Bale plays Batman here. I want the information that he played Batman. How do I do this? Do I put it in parentheses? A new table, also with a comma separated list, and then there's a correspondence. That's not a good idea. So, okay, that's not a good idea. So let's just do it like this. And again, I have look away. It's a new lecture, so these things can't all be perfect. Just look away. You haven't seen this. You haven't seen this. So maybe that's a good, is this a good solution? Let's just repeat. I mean, it's tables. I can only have one thing in each row, so just repeat it. Shawshank Redemption, 1994, 9.3, Morgan Freeman. Shawshank Redemption, 1994, 9.3, Tim Robbins. One row. If a movie has 27 actors, I have 27 rows. Actually, not that bad. And actually, if you do queries later, you will get exactly such tables. So actually, you might say, that's a stupid idea. It's actually a good idea, but you shouldn't create tables like that. If you create tables like that, just think about typing it, but it's very redundant, right? I mean, I have the title now 27 times, and the database has to store it 27 times. Maybe it uses compression, but it's not a good idea. So there are some queries in the chat. No, because, oh yeah, that was just better a new table just for actors and link it. Okay, you're already looking into the future. Yes. Exactly. Yeah, you are just thinking with us. So in the chat there's already some discussion on how to do it. But that's not too bad. You have a question? Okay, this is, now I have a problem understanding you, because it's either you have to speak up or someone has to close. It's actually a bad table because you have two actors with the same name, but you have no way of... Ah yeah, that's another very good point. Another very good point. What if I have two actors called Morgan Freeman? Then I have a problem. Another very good point. Thank you. So, we have two problems. We are repeating information, and it's a very good point. We might have two actors, we might have two movies with the same. Okay, let's look at the third solution. Have a new, and somebody already proposed that, separate table. So, yeah, and I haven't, look away, just look away, just look away. Copy effects to slide. Bam. So I have a separate table where I just have this information. So now I don't repeat the year and score information. I just say, okay, the movie, but here I have some repetition. So I say, okay, somehow I need this maybe. This movie has this actor, this movie has this actor, this movie has this actor. And the year and score information is in the other movie. And I would create it like this. So whenever I specify a schema now, I will just write the command which you would write in a database management system. This creates, and this is also wrong here because cast is missing. I have to specify the name of the table, and the semicolon is also missing. Yeah, these are just normal things when you create new slides. So that's much better. And also note, if we wanted now additional information about the role, so for example, Christian Bale is playing Batman in The Dark Knight, could just have an additional column here with role, Batman. It's very easy now, very natural. So that looks good. But there's still a problem, and you named it. You named the problem. So let's just go to the next slide. here it says this guy plays in this movie. She plays in this movie. Well, a title looks like it's unique, but it's not. There are 3 movies called All Quiet on the Western Front. And let's actually, so one from 1930, so it's a very popular movie. It's after a popular book about the First World War. And there's a remake and there's another remake. And actually, here's the Wikipedia page. This is why you have so many, there's half of Wikipedia pages are disambiguation pages, right? It says here, yes, okay, not, yes, I will donate money, but not right now. See, there are 3 movies here. So if you just say All Quiet on the Western Front, it's not clear which one, not now, which one you need. And there's even a song, there's a book. So that's not unique. Actor names, oh yeah, I found one for you, Anne Hathaway. There's actually at least 2 Anne Hathaways. I mean, there are many Anne Hathaways in the world, but there are 2 actresses. One, the one which you, do you know Anne Hathaway at least? Yeah, okay, I see some nodding. And there's one born 1556. She was also an actor, and she was the wife of William Shakespeare. Okay, let's see, as again. Yeah, Anne Hathaway, wife of Shakespeare. It's even written there. And there's Anne Hathaway, the American actress and singer. So, very important to understand. These are simple concepts, but you have to understand them. Names are good for human communication. I say, do you know Anne Hathaway? You say, yeah. And you think of the Anne Hathaway. You don't think probably of William Shakespeare's wife. If you are into history or something, you will probably ask which one, or you will think it's that one. And the URLs of Wikipedia pages are actually a very good example, right? So if you, Wikipedia pages, if I go to here, that's Anne Hathaway. The Wikipedia page is just called Anne Hathaway. And if I go here, it says that it doesn't say Anne Hathaway 2, it says Anne Hathaway in parentheses, wife of Shakespeare. So that's the solution Wikipedia has found for that problem. By just, if there are many of them, one of them gets the name without further notice, and the others get the name with something in parentheses. So that's also a way. We could have also done that, right? Making names unique by adding something. That's actually, you encounter that a lot. Yes, cities, for example, Berlin, there are probably 17 Berlins or 27 in the world. So what do we do? And you already said it in the chat. We also have IDs. And so for example, for tables, for movies, I just add an ID for everything. I have a separate table with persons, and I have a separate table with the cast, and I will just show you an example here. So this is how we will do it. And there's already, I mean, I could have just shown this to you, but there's already significant thought and understanding all the problems behind it. So this is really, really important. And that's maybe the most important non-trivial thing to understand in this lecture, why this is not only a good, but really the canonical and the best design for this kind of data. So I now have a table for movies. I'm not saying which one is which because it's obvious. Table for movies, like before, but I have something for the ID. What do I take as ID? I mean, here I have one row for movie. I could also have taken 1, 2, 3, 4, but I took the IMDb movie ID. IMDb has, let's just, where do we have it here? Fargo, right here in the URL, maybe a bit small for you. That's the IMDb ID. So actually every system will have their own IDs. Wikipedia pages have their own IDs, and we have seen Wikidata. Let's just look at Anne Hathaway here. Here she has, Wikidata is for all languages together. They also have ID of the form Q386301. IMDb has their IDs, they start with TT. And Wikipedia articles use text and with parentheses stuff to make it unambiguous. So we have the IDs here. Now we have a table with persons. It could be any persons, does not have to be actors. We can easily add more information here. I added birth date, and Yeah, here I took Wikidata IDs. For the exercise sheet, it's up to you which IDs you take. And now I have a third table, and this table is now already hard to read for us, but that's the way to go. What's this information? Well, this says Q48377, which is Morgan Freeman, acted in the movie 172241, which is the Shawshank Redemption. Now I got rid of all the problems. I don't have all the problems I named. And you see here, one thing remains, but that is inevitable. This you also need to understand. I do have repetition here, right? There's nothing like the movie here is just there once, and then I have all the actors comma separated or their IDs. I'm repeating the movie here. If I have the Shawshank Redemption has 27 actors and they are cast, I will have 27 rows with the same movie ID. Which, by the way, is why compression is very important for database efficiency. But I don't think we will have that in that course because we have so many. Usually I have a lecture only about compression, but you have these rows with runs of the same number, and compression is just super important when you store this. Okay, no more new questions on the, let's see when, yeah?
Did we just discuss the 5 normal forms?
Come again?
Did we just discuss the 5 normal forms in a database?
The normal forms, what do you mean?
When we normalize the database to more simpler tables like this.
So what exactly is your question?
Is it the same as normalization?
Is it the same as normalization? Okay, let's see what's defined as database normalization. So what's the difference? It's a good question. What's the difference between normalization and design?
The 5 normal forms.
Yeah. This is now a question about terminology. I always use database design for this. You now ask what's normalization. Let's maybe take this offline. It's a question about terminology. It's a good question. So right now I don't understand the subtle, we can also search database design and see what it, yeah. So it kind of looks similar, right? Design, so I'm not sure now what's the difference. And if maybe there isn't a difference, maybe it's used synonymously. Okay, this may be and now I think we will make a break in a second. And before we do the break, let's go to the exercise sheet so that you understand. And please do the sheet. It's a very nice sheet, it's simple, and you learn a lot. And just so that you understand why we gave the exercise the way we give it. Now, exercise 2 is come up with something like this yourself. And now the data is more complex for the exercise sheet, right? You have movies, you have the year, you have the score, you have who directed the movie. A movie can have more than one director, producer can have more than one producer, actors, you have the Oscars, you have who won an Oscar for which movie. There could be more information, but that's it. And what Oscar is it? And the question is, how do you organize this into tables? 1, 2, 3, 4, 5 tables. And if we would have given you the data, we would have done the job for you, but it's your job to think. And do this exercise, because this could also be a task in the exam, where you have to come up with a design yourself, and you just have to do it once to understand why it's non-trivial. So that's why we let you gather the data yourself, and then you have to, and it's so few data, so you have to just type it into TSV files yourself, and then come up with your database schema. Okay, and I think that's a good point to make a break, and we resume in 5 minutes. So this was like the most important slide. Let me just say it again. This I could have just given this to you and you would have said, yeah. And I don't repeat it again. I just repeat the meta statement that there's a lot of thought and reasoning behind putting the data in tables like this. And this is something you should absolutely understand, and I recommend doing the exercise sheet. And it's non-trivial. You already see it by looking at the tables. Okay, and here comes another thing, primary key and foreign key. And I think it's best understood. So are you back listening to me? So we have these IDs here, and the IDs are called keys in the database world. So here in the table, there's always a table introducing the ID, which is this table for movies here. So this is the first time, I mean, there's no order of the table, but this table is kind of introducing it. So I have a line for every movie. So this here is called the primary key. This column is called the primary key of this table because it defines the IDs. Here I also have a primary key. It defines IDs for person. And just note, I can use the same column name in different tables. Nothing wrong with that. And here I am using the ID. And I don't have to call it the same way. Actually, I can't call it the same way. I can't call it ID. I mean, I have to give it different names, obviously, in the same table. So here I call it movie ID. But this, I can tell the database, look, these IDs, and I should, are actually these IDs defined here. So this is the primary key. This is the foreign key referencing that primary key. That's simple enough once you have understood this design, and you can tell that to actually it's in the, that's what I just explained, and that's how you specify it. It's just like before. The only difference here, let me underline it, is that's the only difference to before. I just write at the end, I'm creating that table. This here is primary key. And now the database know, okay, that's the table introducing that ID. I do the same for persons. And so this is compared to what we had before. That's the new thing. And now if I have a table cast, that's what's new before. I'm saying, okay, here's an ID, and actually that refers to an ID defined in a different table. So I can just, that's just the way how you specify this in SQL. And then you have the advantage that the database can do checks. I mean, you can omit this, it's still correct, but if you do that, and now you insert something that references an ID, and that ID is not there, right? That could easily happen now here. I enter something here with an ID that's not in that table, then it will say, meh, there no such ID there. And also, if I insert another movie here with the same ID as one that's already there, then it will say, no, ID has to be unique. So that's why typically we will have, you will do that. And since keys are something that's succinct, often integers, the efficiency overhead here is okay. But it's just important, it's important for the integrity of your database. Right? If something goes wrong here, everything goes wrong. If you have the same ID twice, or here you reference things which don't exist, probably you have mistyped, something is wrong. So that's a very important integrity check. Okay, and I think, yeah, let's just do that maybe as a preparation for the last part. And I think I have, so that's the second part. I've just prepared these movies here. Yeah, I don't. So now I have my movies file here. It looks like this, and maybe let's look at them in file form. So that's the tabule. It's just looking at. Okay, that's this movie. That's then we have persons. That should be now exactly the table from the slide. So we have just 4, Morgan Freeman, Tim Robbins, Christian Bale, and Maggie Gyllenhaal. And then we have cast. Oh, I called it roles here because cast is actually a keyword in SQL. That's why the name is a bit unfortunate. So that's exactly, I hope, the data from the... Okay, now let's just... I would say we just read this into our, and let's just Yeah, let's maybe do the following. Let me read the files here in that file for a second, just so we see them. No, that was not the one. So let me just do the following, and you will see in a second why I'm doing this. Movies TSV, so that's the movies TSV file. Let's persons TSV. Let me just read it into the file so that we just see it. And let me also do cast roles TSV. You see it here when I do cast, it's highlighted because it's a keyword in Sparkle. So it's not a good idea to call this table cast. That's why I called it roles TSV. Okay, so these are my files. I will delete them in a second. It's just so that we can see them. And now I wanted NeoVim. Okay. Now I want to create the tables for them. So let me create the tables for them. And you see, I get, that's also amazing, right? So this is, I'm showing this to you. I mean, I could deactivate it, but actually I'm showing it to you on purpose. This is, let's go to the slide. Where are the slides? Yeah, let's look at that one. That was what I wrote here on the slide. I'm sorry. ID text, primary key, title text, year integer, score real. It's not, it's one thing is different. What's different?
ID is integer.
Yeah, ID is integer. And I'm saying ID is text because I'm using text IDs here. I mean, that's okay. I can also say this is an integer. I'm making it a little more inefficient, and actually I don't have a space here. And so that's my line. So that's creating this table. Now I want a table for okay, see it learned that I'm using text here. I think that's the right birth date. Okay, for date, actually I want date. That was not quite correct. And roles. Okay, it's doing it a little bit differently. So here I have movie ID text references movies ID. There are different ways to say this in SQL. Let me just, okay. References, and I don't want the primary key. Okay, that was on a... I thought about whether I should show you this or not. It's pretty amazing that it's completing these lines, right? That's pretty amazing. I mean, I just have the tables here, and you have to understand quite a bit, right? It has to understand what this data means. That's why I pasted it here. I thought about whether I'm showing it to you because maybe you're also using this, or now you want to use it. It's a very useful tool, but it's super dangerous for learning, right? Because you saw, I mean, it does it, but it's making these small things differently and sometimes also wrong. It's making mistakes. And if you just use this while you're still learning, you are not learning, you don't recognize the mistakes. It's a gigantic tool. It's amazing. It's magic. But it's very dangerous when you're just learning. So be very careful, don't use it, maybe use it, but then be very careful. That's very important. Okay, now we want to read the files. So we're creating the schema, and now we want to create the files. Okay, I don't even have to, not bad, right? But that was like boilerplate almost. Okay, and now I think we can delete these files. Not bad. So, and now we could just for fun, have a select query here. Yeah, why not? Select movies, thank you. And now I can just do the same thing as before, SQL, pipe this. Now, this is also what you will do for the exercise sheet, just for your data. There's more data there. I pipe these commands, right? Let me just show them to you again. This is just create a table, import the data, ask a query. You can do this all in one. And just note how simple this is, right? It couldn't be any simpler. So, except that it's wrong. What did I do wrong? So, What did I do wrong? I have an idea. Something with separators, yeah, exactly. It was on a previous slide. The default separator, I'm not sure what it is. Either it's white space or a comma, but there should be a... Yeah, exactly. These are tab separated files, so I should say, you can also write the tab separator like this. And you see, it wasn't, so it's, I have to type this, and now it knows it enough. So what's the question on the, how is the auto-completion tool called, and how can I get, how can I get it? Really, you want to get it? It's a Copilot, that's Copilot, and that's NeoVim. But you shouldn't use it. Only, it's not so easy to install. Actually, I think that's a good safety measure by making it hard to install. So you need to pass a test before installing it. But there, I think, other, I don't know, VS Code or something, I think comes with Copilot. Yeah. Exactly. So let's try again. Yeah, now it works. So now, just understand what I did. It just defined the separator to be tabulator. It created the table. It imported these things. It executed the query. I mean, this is so nice, right? It couldn't be any nicer. You have this powerful software, and this now also works with tables with millions of lines or anything. It just works. And here I have the table, all movies. Very, very nice. So, here's one thing to think about. The relationship between tables. There are actually 4 kinds of relationship: one-to-one, one-to-n, n-to-1, and n-to-m. And let me just look at one of them, and then we just quickly do it for 3 table pairs. 1-to-n, that's a common one, means if you look at the one table, then each ID there can occur multiple times in the other table, but when you look at the other table, then each ID there can only occur once in this table. And let's just, and then, so this is one-to-many. This is, maybe I should write that here, because that are also common names here. So that's also called one-to, and that's not only in databases. That's one-to-many, right? ID here can have many, can occur multiple times here, but not multiple times here, and this is called many-to-many. Many-to-many. And this is called many-to-one, and this is called one-to-one. Okay, and now let's go back to the slide where we had these 3 tables. And now the first question is, when this table is A and this table is B, this table to this table. So we have IDs here. Is this to this to this? Is it one-to-one, one-to-many, many-to-one, or many-to-many? One-to-many, that is correct. It's one-to-many because each ID here can occur multiple times here, but here I have each ID only one. What about this to this? Same, one-to-many, that's correct. Each person here, and what does it mean? Each movie can have many actors. This is also one-to-many because an actor can play in multiple movies. What about this to this? Now these are not directly related, but they are related via this one. Yeah, that's many-to-many, that's correct, for the reasons I just saw. Yeah, every movie can have multiple actors. Every actor here can act in multiple movies. So that's just an aside. It's a, let me just write it here on the slide. Yeah. So one-to-one is rather rare, but so this is movies to cast, so I call it cast here. That was 1-to-n. one to many. This was also 1 to n, and this was n to m, many to many. Many to many. Yeah. Okay. And this is, right, this is typical, understand this, when you have the table with the primary key and related to the table with a foreign key, that is by definition 1 to n. Could also be 1 to 1, but because the primary key is unique. Okay. Last part, SQL basics. So let's quickly go to the exercise sheet. The third part of the exercise, now you have done the hard part, you have done the design, and hopefully you have done a good design, just like I did now. And now you want to ask some SQL queries. And here we just give you 3 examples, and you have to find the right SQL query. In which year was Titanic released, and what's its rating? Who directed Fargo? Which actress won Oscars for which roles in which movies and in which categories? And the interesting thing you will see here is, so this looks like, oh, that's a simple SQL query, but now your data, excuse me, is in 4 tables or 5 or I don't know how many, and you will see that even very simple questions now can have pretty complex SQL queries. And you will learn something while doing it. So I highly recommend that you do it, because it will be very useful for understanding the... Yes, but you shouldn't use it. So that's the last part of the exercise, and you will learn a little bit of SQL. So here's the basic form of a SQL query. We have already seen some. I need to rest my voice for 3 seconds before I continue speaking. We have already seen some SQL queries, and SQL is a very complex language. There are a lot more constructs, but the basic SQL queries often have these 3 components: select, and then you have a comma separate list of column names. I want these columns in my result. From, I have a comma separated list of tables. So far we have only seen 1 table. You can actually have multiple tables here, always comma separated. And then where, you somehow specify an expression, a Boolean expression, which says I want these results in my table. Score greater equal 8.0. We have seen that. That's a Boolean expression. You can evaluate on a row. You look at the row, score greater equal 8.0. If yes, true. No, false. If yes, included. So that's the basic form of a SQL query. And I think just by seeing one example, you already understand a lot. And for today, that's exactly how I'm going to do it. It's actually very hard to define such a query language formally, so I won't do it. We will do it more formally in the next lecture. So there we will define the semantics more rigorously. Today we will just do it by example. And in the following, and that's really all the rest of this lecture, we will understand this query here. And it's interesting. It's interesting and not trivial. Because look what I'm doing now. Now I'm saying from persons, movies, cast. I have 3 tables here. What does that mean? This SQL query, I would say, is now not so easy to understand if you have never seen this before. From 3 tables, and then where this ID from, okay, this from that is did from that. I mean, kind of clear what it does, but why does it do what it does? We will understand that now. And let's go in order. Let's start with from, then where, then select. Because you always need from, you don't need where, and you can have a star here, select everything. So let's start with the one which you always need, which is, And there's again a serious mistake on this slide, namely the semicolon is missing here. Missing semicolon is the end of the universe. Where are white spaces? Where? Oh yeah. It's terrible because I made some changes. Thank you. Thank you for paying attention. So let's start with the from clause. That's the most complicated one actually. And now pay attention one more time because it's important. It's, I think, the most important thing to understand about SQL and database queries now. So here's an example queries. No where clause, and I'm selecting everything from 3 tables now. What does it mean to select from 3 tables? If you have never seen this before, what does it mean to, and let's look at my tables here. Let's just do that for TSV in star.tsv. Let's just look at them here. Echo the table name, echo show the table, and let's do it nicely so that I don't have to switch between the slides. And you also learn some things. You learn how to write for loops in Bash, how to not write for loops in Bash. That's because there's a do missing here. No such file, yeah, because TSV files have a, you have to tell me when I'm making mistakes. So, there we go. These are our tables, so yeah, some basic Bash scripting everybody should know, just how you should know all the movies I'm talking about here. Okay, so, what does it mean to do select star from these 3 tables? What does it mean? Is it any ideas? If you don't, or if you already know it, I think you shouldn't say anything. If you don't know it, what does it mean? I mean, that's a query you can type. I mean, it's not a query you can type because the semicolon is missing, but I won't add it now because then you will see the rest of the slide. What does it mean, select star from these 3 queries? Any ideas? Yeah?
Select each row from every table.
Yeah, select each row. This is, I think, very natural that you get the 3 queries back to back, but that would be hard, right? Because the result is 1 table, and these have different, you can't concatenate them, right? It doesn't work. Because you always need 1 table with, every row needs to have the same column. So concatenation doesn't work. Yeah? Yes? Okay, now you're talking about repeating things from the flow. So you already have an idea. It goes in the right direction.
I think named formula. If you think of tables like sets.
Tables like?
Like sets. Like formula like
sets.
That you learn in mathematics. I think it's
very good.
Cartesian product of like.
Okay, very good. You named a lot of very good ideas. So if you think of table like sets, which is how we define them, and now we have the product of sets. You said Cartesian product. So maybe you know some mathematics already, sets, Cartesian product, and that goes in the right direction. Actually, that is exactly the right. But it's kind of not obvious if you have never seen this before. And let me very quickly go to, that was slide 28, to our definition, which you maybe forgot in the meantime. A table is a set. And now we are having 3 sets, and we want to combine them somehow. And let's go back, we are here. And actually what the query does is, if I have, let these be my tables, k tables, so I can have any number of tables, then this query computes the cross product, Cartesian product. So let me use that Cartesian product, that's also right. This is also called Cartesian. Why is it called Cartesian? What does Cartesian mean? Cartesian? Yeah, René Descartes. It's after René Descartes, who said funny things like, I know, I think, therefore I am, and such things. And he also computed products of sets, apparently. So, cross product. And this is, what is the cross product of sets? And I have 2 slides on this, because maybe you have seen this before, maybe not. Intuitively, it's all combinations. You have 3 sets, and now I take all combinations. And before I go back to that slide in a second, let's just understand it for sets. Let's just do it by example. The formal definition is when you work on these slides yourself. Here I have 2 sets. That's like the simplest example maybe. So the result is also a set. And now it's a set of tuples, and I give you the first one, and then you are also language models, in case you didn't know. We are all language models. That's my strong hypothesis. No difference. Your brain works just the same. What's next? What? A, 2, okay. That's one way to do it. I want to do it in this order. B2. What's next? B1, sorry. That's stupid. I have to write it a little bit smaller so that I don't... okay. I start with A1, and now I vary. You need to find a B1. What's next in this schema? What does your autocompletion say? A2, yes. A2, B2, exactly. And now I have A3, B3. Exactly. So it's all combination of an element from the first set with an element of the second set. And there are 2 ways here. I could have varied. So here, this is kind of, you can think of it like in a binary representation or p-adic representation. So this is like here the most significant digit, and this is the least significant digit, right? I could have also written it without sets or comma, just like this. Just to A1, B1, A2, B2, A3, B3. And note one thing, and maybe let's go back to that slide for that to just show that. Check this at home, I'm just saying it here. What's the number of the size of the, it's the product of the sizes of the individual sets, and the number of columns, okay, you will see that in a second. But let's just write it down here. So the size, and there's another example here. So let's just, what's the size of S1? How many elements in S1? 2. What's the size of S2? 3. What's the size of the cross product? What? 2 times 3, yeah. 2 times 3, 6. You could just count. What's important to understand, and that's also why it's called product, the size of the Cartesian or cross product is the product of the, and you should understand this. For sure there will be a question about this in the exam. You have to understand this mathematically. It's not hard, but you have to understand it. This example we don't do by hand. I have written it down for you here. Here I have and let me just write down the sizes as well. You can check in the meantime. So here I have a set of size 2 multiplied with a set of size 3 multiplied with another set of size 3. Of course, they can have the same sizes. And the size of the cross product is What's the size of the cross product without counting? 18. Yeah, it's 2 times 3 times 3. And if you and understand why that is so. There's something to understand here. Don't just learn you have to multiply it. Understand why you have to multiply it. This is the cross product for sets, and now we do the cross products for tables, and that's actually very similar. And this is really the one thing you have to understand about SQL and databases. And now this was actually a lot of work because it's hard to show this on a slide. Now I just take reduced form of the tables on the previous slide. I omitted birth date, I omitted year and score, not because I have to, because otherwise I can't show you the cross product on a slide. This is why, merely for presentation reasons. And here, and now it's the same. This is a set with 2 elements, 2 rows here. This is 2 rows, and this is 3 rows. And now pay attention, this is the cross product. That's how it looks like. And this is like the central slide of understanding SQL queries. This is when I do a cross product of 3 tables. And this is not so easy to understand. And so what we see here is, so this here comes from the table movies. This here is the part from the table persons. And I had to do some magic here to fit, but I think it's quite readable, right? And this here is cast, which I in my code called it roles because cast is a reserved keyword. So now I have, conceptually it's easy. I have every combination from a row from that table with a row from the persons table with a row from the cast table, right? And I had two, and this should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, because it's 2 times 2 times 3. Any questions about this? This you really have to understand SQL. And it can't be any other way. And this, I think, is the... Okay, and now when you understood that, I'm sorry. So the idea was to wiggle when funny sounds. So now, and actually let's do that for our, now I have a different sound, of course. Let's just do that by going here and doing select from movies, persons. That's now the full, and this is mini tables, right? Select star from, let's just look at this. Maybe it was a bit too fast. I do the usual thing here. Select everything from movies, persons, roles. How large, how many rows will the result have? $80, 120, what? 125. I think it's 80, isn't it? 4 times 4 is 16 times, but maybe do 4 times 5 is 20 times 4 is 80. So it's 80. Let's see whether it's 80. And we have, I have to now, I could also do it interactively, but let's do it like this, more fun. Okay, let's pipe it into less with line numbers. It's, okay, what did I do? I'm surprised that oh no, wait, why is it 150? The headings?
I just saw the headings included in your lesson.
The headings were included, yeah. Why are the... Oh. Oh, I see. How do you know how to exclude the headings when importing the data? The TSV headings, we don't know, so we have to, okay, let's quickly do that. Sorry, let me just, let's quickly do that. Okay. Yeah, because I specified it, the schema in the database file, so now it's 80. And now, look, this is a bit hard to see, because now, let's maybe do it like this. This is now all combination of, it's just what we saw on the slides, but just with more. And you see, even for this simple example, it gets huge. So it's actually doing that. It's exactly what you're seeing here. Okay, now the rest is simple. But this is, I mean, I say it now and you say, yeah, but this you have to understand deeply why it has to be done like that, why that's the right way to do it, what it means. You have to spend time yourself. Do the exercise, it's the only way to learn it. Now the rest is simple, once this is clear. The where clause, and I said I do it by example, and this is not quite correct here. This is, I said selecting all columns here. Now I just do the same thing as before, our 3 tables here. Here I call it cast, and now I have a condition, which is just a Boolean expression which I can evaluate on each slide row, right? Now for each row I just check what's written in the where clause. Is it true or is it false? And we will do that in the following. And one thing to note here, I said I introduced SQL by example. Now I prefix the column names by the table. So that's how you usually do it. Table name dot column name. Why do I have to do this? Well, here I have ID, for example, twice, right? Which ID do I mean? I have to say movies dot ID, then it's that one, persons dot ID. Each of these columns comes from a certain table. So that's simple enough to understand. So that's why you write this. Actually, SQL allows to drop it when it's unique. So for example, title, I don't have to write movies.title, I can just write title because there's just one title. SQL will allow that. For ID, it will not allow that. Name. That's also, you don't have to call this person's name in the column, right? Because in the table persons. You don't have to call this person ID here, it's in table persons. That's why I chose that naming. But in that table here, I have to call it movie ID, person ID, because I can't call them both ID. Okay, so, and now what it does, what this query does, it's now really simple. You have the cross product here, or Cartesian product, and now I go over each row and just check this condition. And now remember this condition, and let's do it together for the table. So for each row from this big table, we just check cast person ID is person's ID, cast movie ID is movie's ID. And let's just do it together. And before we do it, you can already warm yourself up. I'm just, so this here was the table movies. This here was the table persons, and I don't have space to repeat the condition, and this was the table cast. And now I want to select all those where ID is equal to movie, where this ID, let me just do it, this ID should be equal to movie ID, this ID should be equal to person ID. And now let's play this game, and you tell me for each row whether, first row, yes or no? Yes? Okay, yes, so let's do that. Oh no, that's wrong. Eraser. I need some highlighter here. Let's take the highlighter, maybe not. Okay, yes. How do we do it? Maybe like this. This one we take. Second one? No. Third one? Fourth one? Fifth one? Yes? No. I hear no. This one? Yes, okay. So now we are doing what the database does. And look, it's kind of irregular. You have to understand this. This one? This one? This one? This one? No? This one? I heard there must be one more yes here. The last one. Oh yeah, the last one. Okay. Actually, I didn't. Okay. And I won't explain this now. You have to understand this yourself. So now we did what the database did. So we kind of just went through it and checked the condition. But what we get now we get who acted in which movie, right? We get Morgan Freeman in The Shawshank Redemption, yes. Morgan Freeman played in The Dark Knight, yes. Maggie Gyllenhaal played in The Dark Knight, yes. So we get these three. And there's no pattern here or something we really had to check. So we get this result now. And I'm not explaining this now because this is something you have to understand yourself. I just showed you how conceptually the database does it, but you have to understand why this does what it should do on the level of what we want, right? Why does it give us now the actors for each movie? This is something you have to understand yourself. It's not trivial. So now we get exactly, this is exactly the cast for our tiny little example. And we even have many-to-many here, right? You see it now. I said this earlier. So this actor plays in two movies, Shawshank and Dark Knight. And the Dark Knight, so Batman movie, has two actors here. And now the last one is really simple. Select clause. Same thing here. Now I select some columns. And what this does, this summarizes like this last part of the lecture. So what does select from where query to? It takes all the rows from the cross product according to the from. Then for each of these rows, it checks the condition of the where clause. We have just done it. And from the result table, it just selects the columns which you write here. So if we go here, now it just says in the select clause, I think I just said select this column here, title, and this column here, name, and then I get this table, right? That's what the select does. So the where and select is really simple. The from part is hard. It does this cross product thing. Then the where selects rows, the select selects columns. And this is my final result here. So now I have the cast for each movie. And you see, I do have the repetitions here, like in my solution 2 in the beginning. Yes?
So a database would have to go through every single Cartesian combination.
That's why there are 2 more slides. It's a great question now. It's an absolutely great question. Explanation, it's like you foresaw what's on the slide. Explanation versus what an RDBMS actually does. The semicolon is missing. Thank you for spotting mistakes, not 1 week before the exam, but now. This is how it should be. Oh no, now I discarded accidentally I will add them in the end, I'm sorry. But it doesn't matter. It was just a little bit. No, it was just the last ones I added. So now so the previous slide, was the explanation wrong I gave you? No, it's absolutely right. So the semicolon is part of the dot here. That is not how a database actually computes the result. Why not? Well, because look, even for these super baby tables, I get this huge, product of sizes, that's just huge, right? It can't be iterating over a cross product of many tables. This would be way too expensive. But important to understand and this is really important to understand, when this is my query, then that is the result. That's just the correct result for that query. Database can't do anything different, has to produce these. When I you shouldn't ask that query. That's a query you shouldn't ask a database. It will just be huge. But when that is the query, the result is the cross product. So a database actually computes the cross product. But typically, and that's what I wrote here, so when you don't have a where clause, it has to compute the cross product, and it will. We just saw it. But very often you have these where this column is equal to this column is equal to that column. That's called the equijoin. Don't have to understand this now. We will see it in the next lecture, and then you can do something much more efficient. And that's key to efficient databases. But that's not the topic of today. That's the last slide. The point of today's lecture and also of the exercise sheet is you don't have to care how the database does it. Does it really compute this cross product? Does it do any other way? The point was to understand these basic concepts, how to create tables properly, how to use SQLite 3, and how to ask simple SQL queries. Just going back to the sheet, right? Here you just, now you have your design, might be little bit different for every one of you. And now you have to, okay, how do I ask SQL queries for this? And really, if you want to understand databases, you should do the exercise. It's a super fun exercise. We spend a lot of time on it. Here's the original paper, some Wikipedia article, SQLite 3. I showed that to you earlier. Is there any questions about anything today? No more question. Frank comes in, so we are done. Thank you and have fun with the sheet. Bye-bye.